Okay, so the question says we are given a string which contains increasing and decreasing I and D as characters, and we have to form one number which uses digits from 1 to 9, which follows this pattern. For example, if you see if this is I, from 1 to 2 we are increasing order, then again I 2 to 3 also there is increase, then there is I, there is another increase, and then there is D. From 5 there should be a decrease, then there is a increase, decrease, decrease, decrease. So ideally multiple patterns are possible, but we have to find the smallest possible string that meets these conditions. So this is what this question wants from us. Given the pattern, we have to produce the output of numbers. And this output of numbers that it is asking us to do, what concept comes to your mind when it comes to like give some arrangement of these numbers? Can somebody tell what are the key concepts you thought or you think would be required for solving this problem? Okay, Vamshi, Madhusudan, they are saying backtracking, fair. Greedy, okay, some sort of optimization. Backtracking, okay, you're right. Like one concept could have been backtracking. We'll talk about multiple solutions here. Backtracking. Okay. In backtracking also specifically, can I say that if I want you to give me a pattern, it is saying this number contains a 1 to 9 where each digit will be at most 1. If I ask you, I give you 4 digits. If I say there are 4 digits, 1, 2, 3, 4, how many total patterns of 1, 2, 3, 4 are possible? Be it any string, if there is a string of length 3, how many total permutations are possible? So we know 4 factorial permutations are possible. And 4 factorial permutations, out of them we have to validate which permutation is meeting the criteria. Okay. Second thing, yeah, this we are talking about, this may be related to permutation. We will see that. Second is, if input string length is, let's say 5, what should be the length of output string? It will be 6. It will be one more, of course. Yeah. Okay, so one very naive approach that we can think of is, we say, let's say if your input is of length n, input length is n, then we are actually going and generating all the permutations of numbers from 1 to n plus 1. Is that correct? Generate all per okay, who is this? Yes, can you please mute yourself? Okay, so we have to generate all permutations of 1 to n plus 1. If we do that, then what we have to do is we have to validate which permutations match the given string. Let's say I give you a string of length 3. Let's say the string is DID. Okay, if this is the string, then our output is going to be of length 4. And I generate all the patterns of length 4. 1, 2, 3, 4 is the first permutation. Let's say we put this in a string without any spaces in it. Now, how difficult will it be for us to validate whether 1, 2, 3, 4 matches DID pattern or not? Is it easy for us to write a function that takes this string, this permutation, and tells whether this matches or does not match? Yes, it will be easy to write that. And the time complexity of doing that will be big of n. Yeah, because we'll have to at least go with this or this one string we have to exhaust. So if we generate all the permutations of size n plus 1, then permutation generation algorithm will have n into n factorial, and validation of that takes another n time. So if we talk about like this is going to be the time complexity if we go with every permutation and then validate whether that permutation meets this, and then we give the answer. If this be the complexity, if we go and think in this direction, first thing we have to validate is, will this solution get accepted? Let's look at the constraint. Constraint says pattern length will be 8. That means we are talking about n to be 8. So it is 8 into 8 into 8 factorial. Or even if we think the output is going to be 8 plus 1, so let's take it as 9 into 9 into 9 factorial. Can you quickly do a computation and tell me roughly this will be how much? 10 power what? We are just evaluating whether this brute force, this way of thinking will get accepted or not. Okay, Akshay is saying this is nearly 10 to the power 7. What about others? What do others say? Yeah, guys, waiting for your responses. A rough number, roughly it will be equivalent to. Okay, Srinivas has given exact value of this expression. So this value he has given is 2242617. It's 2 into 10 power 7, let's say, which is nearly 10 power 7, which is less than 10 power 8. So this solution ideally should get accepted, right? Yes. So, and of course, you can write your own formula for permutation, your own logic for permutation generation, or built-in languages have built-in function for generating permutations. C++ has next permutation of a string, you can say s.begin, s.end, and Python has permutations. You can do permutations of a list. So we could have used built-in functions and we can solve this problem using that. Okay, so this is one approach that could have led to a solution which is still acceptable. Now let's talk about one more approach. Any questions from anyone on this permutation-based idea, permutation-based logic?
Yeah, Sandeep, one question.
Sure, go ahead, please.
So the number can be anything, right? So the next permutation it doesn't guarantee that like it gives the in the order that the sum is minimum or maximum as per the constraint. I think they have mentioned that, right?
Yes, so basically next permutation will give you invalid patterns also. For example, let's take an example. Di is the string. So you are going to take all the permutation of 1, 2, 3. Okay, 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and 3, 1, 2, and 3, 2, 1. These are the 6 permutations possible.
Yeah.
So now you are going and validating, is 1, 2, 3 matching Di?
Okay.
Is it matching?
No.
No. So move to the next one. This doesn't match. Is 1, 3, 2 matching?
No.
No, because first it is increasing, then it is decreasing. No. Is 2, 1, 3 matching?
Yeah.
This is matching. Let's continue. I'm not stopping here. Let's continue. Is this matching 2, 3, 1?
No.
No. Next one, is that matching? 3,
Yes.
1. First it is decreasing, then it is increasing. Yes.
Yes.
Last one?
No.
No. So basically, you see every pattern that is matching, even if let's say, even if we are not sure whether the next permutation generates them in lexicographical order, then it is all about going to every permutation and checking which permutation is matching the pattern and finding out the smallest string out of them. What is smallest string out of these two, 2, 1, 3 or 3, 1, 2?
2, 1, 3.
That becomes your answer.
Okay, so we should not stop. Basically, we should continue even if we like get the answer. We have to validate all the answer to find out the proper answer.
See, ideally we can stop when we know, like if you're 100% sure the language is giving you next permutation, which is lexicographically sorted order, then we ideally we don't have to proceed from here. We can stop there, right?
Okay.
Yeah. So yeah, it depends on languages, libraries. I'm talking about just 2 languages here. I'm not sure whether every language provides this function, but if we write our own function of next permutation, we have done that in our course. We wrote next permutation function greedily, which we can take the array and shuffle it to generate the next permutation, right? So then if we write our own function which generates lexicographically sorted order, then this solution will work. Hope that answers your question, Harsha.
Yeah, got it, Sanjay. Thanks.
Perfect. Okay, so this is one. Any other question from anyone? Okay, so this question also tells us, be acquainted, be comfortable with built-in permutation generation function of your language in which you code. So this is one thing that take it as a takeaway from this discussion and try this solution with permutations also. Now we are going to talk about second one. Yes, fellowship, we are coming to the second approach of doing it in some other way. I'll not reveal the data structure that I would see if people can come up with. So let's say the string that is given to us is did. Okay, I'm just taking a random string in my mind. Permutation that we have to output, let's say that will start with 1. So we are having 1 in our mind directly. So output string that we have for this will be of which length? For this input, output string should be of which length? It should be of length 4. And we know in that length 4, it's a permutation and numbers are in increasing order. So somewhere you will have a pattern where numbers can go like 1, 2, 3. Somewhere it will be 4, it will be 6, 5. Somewhere it can be 7, 8, 9. So we see a pattern. Somewhere it can be increasing order, somewhere it can be decreasing order. So some sort of permutation like this will come as an answer. So let me start with 1 here. I am thinking I will put 1 in the first place, and that is where I will get started. So this one I'm considering in my mind, but I'm not outputting it right now. I'm thinking whether I should output 1 or not. That decision we will make based on the character here. My first number is 1 in my mind. Imagine if there was I here, if first character was I, was it fair to put I in the first place? Would it have been fair to put I in the first place? What do you say? If initial character is I, is it okay if I print 1 as the first digit? Can we construct a pattern like that? Yeah, if it is increasing, 1 is certainly the smallest number, and anything after 1 will make that I justifiable. Okay, so making a rule, if you see an I, we are thinking, let's print the number which we have considered in our mind. This is my mind's number. And I also need to keep in my mind my next number is 2. Okay, so first is printed, and now next number I'm going and playing with 2. 2 is the next number. And what is the next character now? D. So when D comes, if I print 2 here, will I be able to come up with a value, a digit after 2, which is decreasing from 2? No. So at this moment, the number I have in my mind, I don't print that. If D comes, I remember this number, and I also remember the next number that I have to move to. Okay, so 1 is printed, 2 is held back in my mind. I'm not printing 2. 3 is the next number I have aligned. I have kept in my mind. Okay, next is I. Whenever I comes, we were talking about printing. Now I have 2 numbers in my mind, and I want you to think about, if I have to print these 2 numbers, how do I print them? Which order should I print them? Okay, Hemant says print them in reverse order. Print them as 3, 2. Does everyone agree with Hemant? Yes. Okay, so output wise, 1 we already printed. Now we are printing 3, 2 because we see an I. And after printing, I will forget about these numbers, they are done. My next number is 4. Okay. When I saw I, we have printed those numbers. Okay. After 4, what is the next number? What is the next character? Next character is D. When D comes, we decided we will not print something. We will start accumulating things in our mind. So 4 will remain. And the next number is 5. We'll accumulate that. Okay. And now we see the string got over. After string got over, whatever numbers we have in our mind, what should we do with them? We should reverse and print. Okay. So we are going and saying print 5 and 4. Okay. So we made some simple rules. We said we will remember a number in our mind. What is the next digit? If it is I, we will print all the things that we have remembered in reverse order. If we see a D, we will keep accumulating the numbers until unless we see an I later, and we will get some output. Okay, this rule we will just try to grasp and understand. I'm giving you a string to think about I triple D, ID, I. Can you take this and tell me what number with this approach, if you try, are you going to get? Yeah, whatever tracing we did just now, quickly work it out and tell me what number are you going to get for this string. Okay, I got one response, waiting for others. This is the idea, this is the logic. So first number in our mind will be 1. Mind has number 1. We see an I, what should we do? When we see an I, what should we do? Yep, print in reverse order. We have only one number. Let's print here. And in mind, get another number. Okay. Next character is D. What should we do? Should we print D 2 or we should wait? We should not print. So that means we'll have another number in our mind, 3. Then next is again D. What should we do? We should have 4 also in our mind. Okay. Next we have I. What should we do now? After 2, 3, 4, we have encountered okay, so we should print them in reverse order and we should clear them from our mind. So it becomes 4, 3, 2. And next number, we should keep that ready as 5. Okay, wait, there was, here it is increasing. Here it is decreasing, decreasing. Okay, one more I missed. Thanks, Falashi, for pointing that out. This should be 5 to this decreasing. We should ideally have 5 also appended and then printed. Okay, so one more number has to be there because 3 Ds will be justified. So ideally we should accumulate 2, 3, 4, 5. And then here we should, when we see the I, this should be in reverse order, 5, 4, 3, 2. And the next is 6. Okay, then we see decreasing. At I, we have added 6 and we have printed these earlier things. Now after 6, we have decreasing, so we should accumulate 7. Okay, then we see an I, so we should have 7 and 6 printed and 8 in our mind. And now we got entire string over. In mind, the number left is 8, so 8 should be printed on the output. Okay, are we clear with the thought process, what we are doing? Yes. Okay, so what is it that we can use to accumulate numbers in our mind and print that somehow? What data structure is appropriate data structure? Yep. So we can use stack to accumulate, and stack is kind of allowing us to reverse the numbers and print the numbers. In place of stack, if I ask you to use double-ended queue, can we use double-ended queue also? Yep, because double-ended queue, you can append both sides, you can remove from both sides. Ideally, it is more powerful than a stack. You can use double-ended queue as a queue also. You can use double-ended queue as a stack also. Okay, so using stack or queue, we can ideally solve this problem with this observation. Okay, so yeah, this is another solution for this problem. Was tricky solution, but it is interesting way of thinking about this problem. Okay, did anyone try any other solution apart from these two? Okay, Akshay. Okay, Akshay used map. Akshay, can you unmute and speak up your approach? Vamshi will come to your approach also. Yeah, Akshay.
First, I initialized answer string. Then I just assigned digits in increasing order.
Okay.
Then whenever I encounter D in character array, character string, I just remember the index of that pattern.
Okay, so for example, when you saw this string, so you are saying you remembered characters in increasing order. So you made it 1, 2, 3, 4, 5, 6, 7,
Yes.
8. Okay, then
I traverse pattern string.
okay, so this
And
is
whenever
pattern.
yes,
Okay.
whenever I encounter D, I
Okay.
store that D value in map.
Okay, so here you first you encountered I. What did you do then?
I didn't store that in map. Like whenever I encounter D, I stored that in map.
Okay, D you stored in map.
No, the index of the D.
Index of D is 1 here. So you are taking a map. In map, your key is 1 and a value.
Like if the D is continuous, like D is it's continuous, right?
Yep.
Yeah. It how many times it repeated, that frequency of D.
So it is repeating 3 times.
Then the next B is at the index of 0, 1, 2, 3, 4, 6.
5.
5.
Yeah, and that occurs one time.
Only one time.
Okay.
Then I modified A.
Okay.
From 1 to the index at 1, 2, 3. I mean 1 to
4.
1 plus 3. Yeah, 4. I reversed that substring in A.
Okay, so basically you went ahead and you said, okay, let me go, and because there were triple D, let me go and reverse that part. So you made it like 1 and 5, 4, 3, 2. Then 6 you are not touching, you will go with index. You will go to index 5, 0, 1, 2, 3, 4, 5. Okay. 5, 2, you will take 2 characters and you will reverse them. 7, 6, and 8. Yeah, Paksha, good thought. And thank you for sharing. This will work. Yeah. Yeah, Vamshi, go ahead with your approach.
Yes, sir. At every index, if it is increasing, I am taking the last element, and from that element to the 8th digit, I am iterating and I am putting one element and calling the function recursively.
Okay, so when you see I,
Yeah, sir.
along with this, you are also passing what you are appending. I
am using a set which has 1 to 9 digits.
Okay. So you basically have a pattern and a set that you are passing. Set
Yes,
has
sir.
1, 2, 3, 4, 5, 6, 7, 8, 9. And your initially your pattern is, let's say, IDDD, IDI. Okay.
First, I am manually appending one digits, sir. 1
Okay.
to 9 digits.
Okay.
So I will call from the first index to my function.
Okay.
So I will first put 1 and then call my function with index 1.
Okay. So your answer already has one added here.
1 add, yes, sir.
Okay.
Then I will call my function with index 1.
And
then
you remove it one from set.
Yes, sir. I'll remove it from the set. Then it says it is increasing. So my function will iterate from 2 to 9,
Okay.
which is last digit of answer plus 1 to 9, and check if that number is present in set. It will append it to the answer and recursively call the function.
So you found 2 is present in the set.
So I'll add it to the answer,
so you
remove
add
it from the set and recursively call the function with index plus 1.
Okay, so now your next character you're looking at is D.
Yes, sir.
And your available characters are these. So when you see a D, what do you do?
Answer of -1, which is last character, -1 to 1. So here I will go from 1, only I'll check from 1. If it is in set, I will add it to the answer. So it is not present. So
One is
it will
not in the
return.
set.
So it will return.
Okay.
So I will pop 2.
Okay.
So then I will add 3.
Okay. So this basically then you backtrack and you say, hey, after
Yes.
1, 2 was not a good choice for me to go ahead with, because if I go with 2, I'm not able to find a lesser value to place after 2.
Yes, sir.
Okay. So you are cleverly generating only those permutations which are going to satisfy this criteria.
Yes, sir.
So I kind of, you are exploring all the paths, and whichever path meets your constraint, you will say that is my answer.
Yes, sir.
A nice, good approach. Thanks, Vamshi, for sharing that.
Most welcome.
Yep. Yeah, guys, everyone understood Vamshi's approach? He's kind of filling.
Yeah, can you repeat?
Sorry?
Yeah, can you repeat?
Okay. So Kumar, here Vamshi is generating a pattern. It's like path printing problems we have done in backtracking earlier. So he's generating the pattern starting with 1 here. So he says first place, ideally in any answer, first place will have a possible digit 1 to 9. Is that correct, Kumar?
Yeah.
So he's going ahead and trying, let me start by placing 1 in first place and see if I get to a solution. If he puts 1 and he sees a D after that, imagine, if he puts 1 here and there was a D as first character, will he be able to find any value to place after 1?
No.
No, because after 1, he has to put a value which is lesser than 1. If he's not able to find that, he's saying this path will never lead to a solution. Go backtrack and start with another option at first place. And that another option is he's starting another option at first place. Let's start with 2.
Okay.
If 2 also doesn't work, he will go and explore another option. What if I would have started with a path having 3? So it's like he's exploring all the permutations he's generating, which adhere to the pattern that is given to us. Is this making sense, Kumar?
Yeah.
Okay. So it is like the simple backtracking approach. You have a path that you want to fulfill, and you have a pattern that is given to us. It's like in current position, for each option, you take step forward if it is possible. If no step forward possible, you are returning back. Otherwise, take step forward, call backtracking again with path and pattern. And then if that leads to a solution, stop, return answer. Otherwise, you say take step backward and try another option. And these are the options. For first place, he's trying, hey, can I start with 1 and get a pattern? Or can I start with 2 and get a pattern? Can I start with 3 and get a pattern? That's what he's exploring. Fair? Any other questions from anyone on this?
I found it really hard to find the time complexity of this approach. If you can discuss it, would be good.
Okay. So very high level, if you ask, name way, if you ask, you are trying a possibility of every place as every digit. Is that correct, Vamshi?
Yes, sir. Yes.
Worst case, if I ask you how many total patterns you will get. Total how many
9
patterns?
factorial.
Yeah, it will be kind of 9 factorial patterns you are getting, but your backtracking approach is cleverly, you can say, pruning some of the paths. You are not creating some of the patterns which are going to be invalid. For
Yes,
example,
sir.
if your string is DID, you will never create a pattern like 1, 2, 3 to begin with, because you will not consider a pattern which is increasing.
Yes, sir.
Your approach will have time complexity less than n factorial because of the pruning you are doing.
Yes, sir.
Yeah. Okay. So typically, a path printing problem wise, we can just count how many patterns we are going to get, and that will help us get the time complexity. Okay, so we are good. Shall we move to the next question? Cool.